numbers tell you is just kind of like a little summary. So like right here, for example, this is a summary of how to graph, you know, sine and cosine functions, and it just kind of gives you some notes and stuff to help you out. So I would use that as a study tool as you're working. So what is b in this case? 2. So that's 2 pi over 2, which is just pi, correct? So the period is pi, which makes sense, because if we're going from 0 to 2 pi, the period is the amount it takes for one full cycle. And since we're going 2 cycles, it would make sense that each cycle is pi long, right? Now, for cosine, where do we start? Do we start at our origin or on our amplitude? Amplitude is correct. So we're going to start right here. But before we really start graphing this, we're going to need to break up our x-axis into intervals, okay, to determine how many different marks we need to make on our x-axis. We can do this by just multiplying 4 times the number of cycles, which would be 4 times b. And in this case, that's 4 times 2, which is 8. Okay? So we are breaking up 2 pi into 8 equal pieces. Hello? Hey. I don't plan on, no. Hold on one second. For that interruption. So we break this up into 8 equal pieces. To determine what the length is between each of these intervals, all we have to do is take our period and divide it by 4. So this was like the first thing, second thing, third thing. Over here, we're going to take our period, which is pi, and divide it by 4. So that just means we're counting by pi over 4. So that's 1 pi over 4, 2 pi over 4, 5, I don't know why I did that, 5 pi over 4. That's actually 4 pi over 4, which is just pi. 5 pi over 4, 6 pi over 4, 7 pi over 4, and finally 8 pi over 4, which is just 2 pi. All right, so let me get a different color to graph this. Remember when we graph, we're always, go like in the same order. So we'll start up here and we'll go top, middle, bottom, middle, top, middle, bottom, middle, top, right? That top's a little too high. It needs to line up with my amplitude. So then we're going to graph this. Okay, do you see how that's 2 full cycles? We go, this is 1 full cycle, it ends here, and then that's the other full cycle. Any questions there?
Okay, so is that 2 pi?
I'm sorry, could you say that a little bit louder?
2 pi.
8 pi over 4 is 2 pi, yes.
Okay.
Okay. Gucci. Number 86. So we're going to do the same thing we did before. Is we're going to first find our amplitude, which is 1. Okay, you're not going to have a negative amplitude, so the amplitude is really just the absolute value of A. Now, the period is equal to 2 pi over b, and in this case, b is 3, right? So that's your period. Period is 2 pi over 3, and the next thing we want to determine is how many little sections we're going to break up 2 pi into, how many equal sections, and we do that, so this is 1, we would do that by multiplying 4 times b, which is 3, and that gives us 12, okay? Okay, to determine how long each of these 12 sections are, what we're going to do is we are going to take our period, which is 2 pi over 3, and we're going to divide it by 4, right? Which just means we're going to multiply by the reciprocal, so that would be 2 pi over 3, not times 4, but times 1 over 4, which is 2 pi over 12, and that simplifies to pi over 6. So we're counting by pi over 6s, okay? Are y'all cool with that? This is 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. Okay, any questions so far? Our amplitude, as we have already said, is 1, so there's a 1 here and a negative 1. Now, for sine functions, where do we start? Do we start at our origin or our amplitude? Origin, right. Now, how do I know if my first point goes here or here? Since it says negative out front, our graph, instead of going up, it's going to start going down. So we're middle, down, middle, up. Middle, down, middle, up. Middle, down, middle, up. And then middle. The amplitude isn't actually negative. Oh, thank you. You're absolutely right. Thank you. That's negative 1. I know it's annoying to graph these when they're so small, but it's kind of pretty, isn't it? Any questions? Do you guys see that there are 3 full cycles here? 1 cycle, 2 cycle, 3 cycles. That's the same as our B. That's what that 3 means, okay? Yes? Like right here? Sure thing. That's the plan?
Yeah, I want to go.
All right.
Well, no, that's fine.
Any other questions here? Okay. Let's look at 87, okay? On 87, the amplitude is 1, correct? And the period for tangent graphs, the period's not 2 pi over b, but it's just pi over b. So this is just pi over 1, which is just pi, okay? Now, the tangent's different, so the next thing we want to find are the asymptotes, okay? And to find the asymptotes, it's just x is equal to your period divided by 2. So x equals plus or minus your period divided by 2. So that equals plus or minus pi halves. So there's a positive pi halves here and a negative pi halves here. These are our asymptotes that are vertical lines say that our graph is never actually going to go there. Now, since this is negative, our graph is actually going this way. Right? But if it were positive, it would be going up and then down this way. Do y'all see that? All right. So tan graphs are super easy to graph, aren't they? We just have to remember. Yes, ma'am? The period is just pi divided by b.
How did you get the x thing?
The x asymptotes are your period divided by 2.
Okay.
And I wrote that like on this little sheet I was telling you guys about, tan of theta graph. The period is equal to pi divided by b. The asymptotes are, maybe I should put x equals plus or minus the period divided by 2. Did y'all see that? Okay, and you can use this to kind of help you as you're working. Any other questions on these graphs? 88? Okay, I'm going to do 88 quickly if that's okay. For negative 4, the period is equal to pi over b. And in this case, what is b?
1/2.
B is 1/2, so that's pi divided by 1/2, which is equal to pi times the reciprocal of that, which is 2 pi, okay? 2 pi is our period, and our asymptotes are equal to plus or minus, the asymptotes are equal to plus or minus your period divided by 2. So in this case, that would be 2 pi over 2, which is pi. And so there would be pi here, negative pi here, and we're going this way this time, right? Okay, what I want y'all to know is you know that this is the period. It's from here to here is the period that it takes to complete one full cycle, right? So if the period is 2 pi, then it makes sense that this is pi and this is pi because that's 1 pi, 2 pi. Any other questions here? Okay, let's move on. Can I flip over? So for this section, you need to know all of these things, right? Remember all that fun stuff? Okay, well, you need to know that. So let's look. Do you have any specific problems in this on this page from 93 to 107 that you'd like me to work out? 102? All right, 102. So on 102, this is the sine of theta divided by the 1 over the sine of theta plus the cosine of theta divided by 1 over the cosine of theta. Well, just give me 1 second, okay? So then this is the sine of theta times, what's the reciprocal of 1 over the sine of theta? The sine of theta plus the cosine of theta. And then what's 1 over the cosine of theta? Times the cosine of theta. So then we get sine squared of theta plus cosine squared of theta. And that's an identity. It's equal to 1. Any questions here? All right. Any other questions? Other questions you guys see on this? Yes, sir.
On this relates to this?
Yeah, from 93 to 107.
No.
You just do 104 first.
104, right. Okay, who remembers this identity? What does the identity actually state? 1 plus cotangent squared of theta equals cosecant squared of theta, right? But in this one, the cosecant squared of theta is what? It's negative, so we're going to have to subtract it. If we do that, we get 1 plus the cotangent squared of theta minus the cosecant squared of theta. And that's equal to 0. But what's here that isn't here? The what? The 1. So let's subtract it. And that leaves us with cotangent squared of theta minus cosecant squared of theta is equal to negative 1. So what is cotangent squared of theta minus cosecant squared of theta equal to? Negative 1. Any questions? Which problem are you talking about? On number 104? Well, I need to know that you know it's equal to negative 1 and not, you don't have to show that work there. I know what you mean. Like, for example, if I just gave you a problem like 1 minus the secant squared of theta, okay, what would that be equal to? Negative tangent of theta, because the tan of theta plus 1, right. It would be negative tan of theta. What if I gave you 1 plus the, let's do, okay, if I just gave you this, what is this equal to? Cosecant squared of theta. So yeah, you don't have to show any work for that. Yeah, but be careful, because did you see how quick people were when they saw this to say cotangent squared of theta? But it's not. It's negative. It's tangent squared of theta. People were quick to say tan squared of theta, but it's not regular tan squared of theta. It's negative tan squared of theta. Does that make sense? Okay. Other questions? Yes, sir, ma'am.
Okay, on 103, I need to multiply by the reciprocal, but like if I do that, will it be sine times 1 or
Well, this is 1 over the cosine squared of theta.
over the sine over the cosine?
I don't know. There's no squared. Sorry. And then you look at this fraction, okay? And in this fraction, it's sine over cosine. So you do the opposite of that, which would be cosine over sine. These cancel. You have 1 over the sine of theta. And what is 1 over the sine of theta equal to? Cosecant of theta. Cool? Other questions? Yes. Is your hand up, Alexia? All right. Any other questions you guys want to, stuff you want to see?
Anything from the study guide?
Let me make sure. Let's just get past this point 93 through 107. We'll get there in just a second. Are we good with this portion? John? Good? Okay. All right. What about on this side? 108 through 116.
108.
You want to see 108?
Yeah.
Okay, on 108, the first thing we're going to do is add 2 and divide by 3, so that gives us the secant of theta is equal to 2 over the square root of 3. Is that correct? Do you have a secant of theta button on your calculator? No. So we need to write this differently. How can we write this differently?
1 over 2.
Well, we know that
1 divided.
the cosine of theta is equal to 1 over the secant of theta, right? So we can reciprocate this and say if this is the cosine of theta, it's just the reciprocal, so it'd be the square root of 3 over 2. Hey, how are you? Do you see that?
Yeah.
Last day.
You just do the
No, that's not the answer yet. I'm sorry.
you have to do the second cosine, the one that the
Right, good. So to find theta, we just put cosine inverse of square root of 3 over 2 in our calculator, and that's going to give us what? 30 degrees? So theta is equal to 30 degrees, okay? All right. Now, all students take calculus, right? If we're here at 30 degrees, let me remind you guys what this means. This means that all of them are positive. This is sines positive, cosines positive, tangents positive. All 3 of those are positive in the first quadrant. In the second quadrant, only sine is positive, which means tangent and cosine are not. This is only sine. This one, only tangent is positive in the third quadrant, and only cosine is positive in the fourth quadrant. Do we want our cosine to be positive or negative?
positive.
Positive. So where does it need to go?
My cosine.
In that fourth quadrant, right? Now to find our other theta, it's equal to 360 minus our reference angle, which also happens to be theta. Theta is not always going to be equal to your reference angle. Does that make sense? So we get 330 degrees. So our answer is 330 degrees as well as 30 degrees. Any questions there? Okay, other problems you guys want to see? No, right now I'm just on 108 through 116. You guys really hated those problems there for a while, so good, very good. I'm proud of you. Any questions between 108 and 116? Okay, all right, we're opening up the whole study guide now. Alvin.
138.
138. You may. In arithmetic sequence, so what we're going to do here is we're going to set up a system using the formula a sub n is equal to a sub 1 plus n minus 1 times d. We're going to set this up with this guy, and then we're going to set it up again. All right, I'll see you later. And then we're going to set it up again with this guy. We have to do a lot of work on this problem, so go ahead and get ready for that. A sub n is negative 20 here, and that's negative 20 is equal to our first term, which we don't know, plus n, which is 3 in this case, minus 1 times d, which we also don't know, okay? And we can simplify this to be negative 20 equals a sub 1 plus 2d. Now we're going to do the same thing with a sub 101 equals negative 902, so that's negative 902 is equal to a sub 1, which we don't know, plus n, which in this case is 101, minus 1 times d, which is our common difference. We can simplify this guy a little bit by just subtracting and multiplying by d, so that's plus 100d. Okay, and now we just need to change the signs of one of these two equations. I'm just going to go ahead and change the sign of this first guy. So I'm just making this a positive, changing that to a negative, and that to a negative. When we add through here, what is that going to give us? These cancel. 82, is that right? 88? Negative 888? Good. And what do we... 82?
Yeah, it's 82.
Okay. And when we divide both sides by 98, what do we get? -9? -9 is D, which is our common difference. Now we're going to plug -9 in to find what? A sub 1. So we can plug them into any one. I'm going to go to the top one just because it's smaller numbers. -20 is equal to A sub 1 plus 3 minus 1 times D, which is -9. And then that would be minus 18. We would add 18 to both sides and we get A sub 1 is equal to -2. Now that we have found A and that we have found D, we can now plug them both in using A sub 55 to find A sub 55, right? So this is going to be A sub 55 is equal to A sub 1, which is -2, plus N, which in this case is 55, minus 1 times our common difference, which is -9. So that's A sub 55 is equal to -2 plus 44 times -9. And what is 44 times -9? 54, thank you. Oh, I'm running out of room. I'm trying to squeeze it in. 54 times -9?
-186.
And then you would subtract 2, and did you get -48?
488.
So that's our answer. A sub 55 is equal to -488. Are there any questions? John. Any questions? Any other questions from your study guide? 40. Wait, are we good with this problem?
Can you go over some on the conic section?
Yeah, I will. He just asked for 41, and then I'll go back there, okay? 42? Did you say 41 and or did you say or? Oh, 142. I'm sorry. Daniel, thank you for being so patient with me. Oh, yes, y'all both want the same stuff. All right, 142. So this is where we have to do that completing the square, and it's like the ugly completing the square. Now, what I'm going to do is I'm going to go ahead and factor a 9 out, and that leaves us with y squared minus 2y plus blank is equal, I subtracted this 9 too, to -9 plus blank plus blank. And remember that the reason that there are those blanks is because if I add something to the left side, I also have to add it to the right side, okay? So to determine, to complete the square, what we do is we take our b value, we divide it by 2, and we square it. So we're going to do that with 6, and 6 divided by 2 is 3, and 3 squared is 9, right? So we're adding 9 here, and then we're also going to add a 9 there. Very good. We're going to do the same thing with a 2. -2 divided by 2 is -1, and -1 squared is +1. But it's actually 9, because this 9 is going to multiply by there and give us 9. Does that make sense? Because we're not just adding 1 to the left side, we are actually adding 9. Okay, and if we add 9 to the left, we also have to add 9 to the right. Any questions there? So, let's go ahead and factor this. So now we know that we need to get the right side equal to 1 since this is an ellipse. We divide everything by 9. Okay, our center is negative 3, 1. What is A? 3, and B is length of the major axis is 6, which is 2 times A, and the length of the minor axis is 2. To find the vertices, we can go ahead and graph this. So we go to the left, 1, 2, 3, and then we go up 1. And we go to the right, 1, 2, 3, and to the left. Those are our vertices and our co-vertices. The ones further away from each other are our vertices, and the ones that are closer to the center are our co-vertices.
Wait, so what's the length of the minor major?
The length of the minor axis, or the length of the major is 2A, and the length of the minor is 2B. A is 3, so 2 times A is 6. That's just saying, look right here, Murphy. The length is just saying this is 1, 2, 3, 4, 5, 6. This is 6, which is the length of the major because it's longer, and this is 2 because it's the length of the minor and it's shorter.
Okay, so you said like just find 2A or B.
2 times A is the length of the major, and 2 times B is the length of the minor. Does that make sense?
Yeah.
Okay. So our vertices are going to be these 2 points, which are 0, 1, and negative 6, 1. The length of the minor, or I'm sorry, the length of, okay, let me try that again. Those vertices are 0, 1, and negative 6, 1, because that's this point and this point, okay? Now, the co-vertices are these 2 right here and here, and those coordinates are going to be negative 3, 0, and negative 3, 2. Are there any questions there? We do need to graph this, so we need to connect these. Huh? Yes, ma'am. I'm sorry. This way?
So what if we don't have anything below like y minus 1 squared?
There's a 1. And any, you could make anything a fraction by putting it over 1.
Okay, but like a lot of stuff that we practiced like on our review sheets, there was just like x squared plus y squared equals 1. So
That's a circle.
yeah, I know, but wouldn't the center be 1, 1? Because technically they're both over 1.
What they're over, the A and the B tell you how long you're stretching it this way or that way.
Yeah.
Okay, the number that's being added or subtracted from X, that's the center. No, ask me. I want to answer your question. Here. C? Yeah. All right, C. Okay, is this sine or cosine?
Cosine.
This is cosine, right? Because it's starting at the amplitude. So we already know it's cosine. What is amplitude? 3, so we know that's A. And how many cycles are there? What is B? B is the number of cycles. B is the number of cycles from 0 to 2 pi.
4, 5.
Okay, why don't we talk about this? We know that the period is equal to 2 pi over B, right? We don't know what B is, but we do know what the period is, right? What is the period? The period is the length it takes for our graph to complete one full cycle, which means for it to get back to where it was. If it starts here at the top and it goes down and it comes back around, boom, right here is one full cycle, right? So pi over 2 is the period. So if we say pi over 2 is equal to 2 pi over b, do you see how I did that, guys? Do you see how I identified the period? The period is the amount of time it takes to complete one full cycle. When I say one full cycle, it's like, think of this as a pattern, and when it gets back to where it started, that's one full cycle. So look right here, Hannah. We start here, we go down, we come around, and we're back to where we started. That's one full cycle. At pi over 2, that's when it's one full cycle. And we know, so that means the period is pi over 2, by definition, okay? So the period is pi over 2, and we know the formula that the period is equal to 2 pi over b. We need to find b. That's our goal, is to find b. So what we can do here is cross multiply, and we get b times pi is equal to 4 pi. And then we divide both sides by pi, and we get b is equal to 4, right? Do you see that?
Yeah.
So our equation is y is equal to 3 times the cosine of 4 theta. Any questions here?
Wait, I have to get 3.
3 because the amplitude is 3. Okay. All right. Other questions?
So, I have to get B pi, because you get, I know that pi over 2 is, equal to 2 pi over B. That's what you have there.
Because the period is equal to 2 pi over b. And we identified our period from the graph. We can look at the graph and see that this is 1 full cycle. So our period is this length, which is pi over 2.
Okay.
So we just replaced pi over 2 with our period because our period is pi over 2.
Oh, I understand.
And then we solved this for b. Okay? We could do the same thing down here on r. So on r, what is this sine or cosine? This is sine. Is it positive or negative? Or what's a? What's a?
It's negative.
What is a? You're right, it's negative, but what's a? Is it 5?
1. Wait, yes.
5, but there needs to be a negative out front because it's going down, correct?
Yes.
If it went up, it would be positive. Now, remember our period is equal to 2 pi over b. What is our period here?
2 pi. It's 1.
Okay, we start here, right? And we go down, and we go up, and we come back to where we started. That is 1 full cycle. Do you see that?
So is it 2 pi?
Do you see that that's 1 full cycle? And the length is 2 pi. So your period is, that's 2 pi is equal to 2 pi over b. If we cross multiply and solve, we'll get 2 pi b equals 2 pi. Divide by 2 pi and you get b equals 1. So sine of 1 theta, and you don't have to put 1 theta, you could just put the sine of theta. Or I need my y equals. This is the equation. And you don't have to have that one. It kind of looks funky there, doesn't it? All right, any questions? Any other questions?
Actually, can you go over J part? This thing's always screwed
The
me up.
cube root?
The
Yes.
J, yeah.
All right, guys, look at J. Hey, guys, this semester exam is 20% of your grade, okay? We have like 4 minutes left, so please try to stay with me. This is the standard form. It's y is equal to a times the cubed root of x minus h plus k, where h and k is this point right here. So the coordinates of that point are negative, is that negative 4, 2? Okay, so we're just going to plug in. Now, you need to know that this is a square root graph where a is negative. You need to know that. It's going the wrong way. Usually it goes this way. Okay, it goes up this way and down this way. So this is y is equal to negative 1 times the cubed root of x minus negative 4, which is actually plus 4, and then a plus 2 on the outside. Any questions on J? Yes. All right, this is a,
Wait, what's the answer?
there we go, right there.
Negative.
This is a polynomial function, and we're going to graph this. Remember, this is where we identify our zeros. Here, x is equal to negative 5, 0, and 4, correct? And at all of these places, we have a double root, right? So this is, and since it goes up, up, remember that up, up is positive and even. So this n is y is equal to x plus 5 squared times x minus 0 squared, which is just x squared, times x minus 4 squared. Any questions there?
You just have to put the 0, did we?
No.
You just,
You just, because it's not going to change it. Yes, ma'am.
What if it wasn't up?
If well, let's look at G, okay? On G, it's going up, down. Okay? If they go opposite ways, that means it's odd, so your degree is odd. And if it ends, if the end behavior is down, then it's negative. So this is odd and negative, okay? It almost looks like it bounces, but if you get real close, you can see it doesn't. That's y is equal to -1 times x plus 3 times x plus 2 times x minus 5. And did you notice how I'm taking the opposite of where it crosses through the x-axis? Are there any questions there? That is an x minus 5. Yes?
Over A or B.
A or B, no problem. All right, let's look at A. Okay, can I move this? All right. We know that our x squared, we have x squared and y squared, right? We don't have anything in parentheses because you can see that our center is at 0, 0, right? Now, the longer one we see goes under the x right here because it's longer. 1, 2, 3, 4, 5 squared. So 1. All right, now our center is different over here, isn't it? 1, 2, 3, 4, 5, 6. 1, 2, 3. Our center is at 3, 2. So then this would be x minus 3 squared plus x minus 2 squared is equal to our radius squared. And what's our radius? 1, 2, 3. So our radius is 3 squared. Our radius is 3, and when we square that, we get 9. Yes, your answer is x minus 3 squared plus, oh, that's a y. I'm sorry, this is a y minus 2 squared.
I thought it was always equal to 1.
That's for, it's true for ellipses, but not for circles. Remember circles, the circles that's what makes the circles and ellipses different, okay?
How'd you get that?
Because the formula is, for this formula for a circle is x minus h squared plus y minus k squared is equal to r squared. And that squared's on the outside, sorry. Does that make sense? All right, guys, listen carefully. Your semester exam is 20% of your final grade. You can replace your lowest test grade with your semester exam. Please look on Schoology. I have all kinds of notes and videos and keys and extra copies of study guides and extra work. I also have copies in hand that you can take with you today of the few problems that were left off the study guide for geometric sequences and theories. Please pass that out. Please remember that today is the last day I will have tutoring for you before your exam. Okay, your exam is not until Monday, but today is the last day I will have after-school tutoring. Please remember that your semester exam study guides are due even if you exempted.